Hello everyone. Today we are tackling a question on integration. The gradient of a curve at any point is given by 2x minus 1. Given that the curve passes through point 15, find the equation of the curve. Before we solve this, I want us to take note of the following. So we're going to recall. When you're given a function, let's say equation of a curve, y is equal to ax squared plus bx plus c. So let's say a quadratic curve. Then we can always determine the gradient function by differentiating y. So the gradient function is dy dx. And this means that when you're given the gradient function, you can always get back to the equation of the curve by integration. So we integrate the gradient function to get back to the equation of the curve. And for our case here, we are already told that the gradient of the curve at any point is given by 2x minus 1. So that means that the gradient function dy dx is 2x minus 1. And therefore, we can get back to the equation of the curve by simply integrating the gradient function. So we are going to integrate 2x minus 1 with respect to x. From here, we are going to integrate each and every term. I want to rewrite this. So still integrating 2x minus 1. So 1 here is a coefficient of x power 0. Remember, a number other than 0 when raised to 0 gives us 1. So x power 0 is silently beside 1. So this is what I want us to integrate. And therefore, beginning with this first term, 2x, we are going to have 2x. Remember, x here is power 1 already. So we add 1 to the power, and that gives us 2. So 1 plus 1 is 2. And then the resulting power divides the entire term. For the next term, we'll have the power of x is 0. So we increase the power by 1. So that gives us 1. Therefore, we have x power 1. X power 1 is just x. And then that power divides the entire term. And then let's not forget about a constant term, c. So this simplifies as x squared minus x plus c. So the equation of the curve is given as y is equal to x squared minus x plus c. Now this is not yet the equation of the curve that we require. We therefore must determine the value of c, and with the value of c inserted, we shall have had the equation of the curve as required. So the next step is to determine the value of c. When you look at the equation, we are told that the curve passes through point 15, and that means if it passes through point 15, simply implies that the value of x is 1 when the value of y is 5. And therefore, we can substitute these in the equation, and that will help us determine the value of c. Therefore, we are going to have, in place of y, we have 5, and in place of x, we substitute 1. So we have 1 squared, that is 1. Remember, we are substituting here. So 1 squared is 1, minus x for 1, that is 1, and then plus c. 1 minus 1 is 0, and therefore c is 5. C is equal to 5. From this, we've already determined the value of c, and therefore rewriting the equation, we determine the equation of the curve as y is equal to x squared minus x plus c, and c is 5. And that is the equation of the curve as desired. With that, we come to the end of this question. Thank you for watching, and bye for now.